or final video with this pedal board, just as an introduction to looking at the Arduino Sketch. I've got all the LEDs on at the moment just to show the lights, but just to quickly go through how this board functions, so when we look at it in the Arduino Sketch, it all makes sense. So at the moment, um, the bypass is on. If I turn that off, watch the indicator lights here for the bypass. That turns the bypass on and off. These ones, I've got labels on them now: 1, 2, 3, 4, boost, delay, bypass, 5, 6, and 7. That was 8. I've changed it to 7. Just copied the same thing to patch 7. So it's going cycling through. Patch 2, 3, 4, 5, 6, 7. The other functionality is when you pick, I've picked a patch 5, patch 3 there. If I bypass it, turns everything off, but it remembers which was the last patch selected. It comes back again. If I go there, off, back to 4, and if it's off and if I press 6, it remembers 6. So that's the basic functionality of the pedal board, and these are the external controls: the boost, and this is running the delay. So these other lights are unrelated. That's for switching my amplifier, reverb and tremolo. This is for switching between input guitars, and I've got my delay lights on just for the fun of it. And that's my tuner there. So lots of nice lights as well. So on to the Arduino Sketch. The video I'll do after this one, the recording I'll do after this one, is looking at the other function I've talked about in earlier parts of this project about the lighting control. So that'll be later, but I will follow up on how this pedal board can do lighting control, and there's elements of the Arduino Sketch that refers to the lighting control, which I'll ignore for now.
Right, here, this is going through the Arduino sketch file, SimpleMan V03, for the practical demonstration where I've put a 10 switch unit in on my pedal board. It's in the video, maybe this one or previous one. Two of the switches are not related to MIDI, they're for controlling other things. So 8 of the switches are related to MIDI commands, and that's about the maximum you can do with an Arduino Nano, having both switches and LED, indicating LEDs, I should say. So there's a previous video on how all this works as it's set up. The minor difference here is I've used a different Arduino Nano board, which is an Arduino brand itself, and that has a slightly different pinout to the previous version, but you can work that out as you go along. And that's all it's doing, is saying there are 8 pins. They are defined as either the inputs for the switches, outputs for the LEDs, and a whole lot of other stuff, which I won't go through again of how to set it up. The other thing to note here is there's a variable I've also set up here called current patch. So what this is doing, if you compare it to the previous video when I went through the Arduino sketch file, it's doing exactly the same thing. Each of these switches in its second state here is in making sure the Chase Bliss automaton unit, preamp unit, is in a state where it's not bypassed, the unit is affecting and engage the signal, and that's from the MIDI implementation table for that unit is system exclusive in old MIDI speak, is a control change value of 102, or command of 102. The value of 1 means the unit is engaged and affecting, and M18, which is the MIDI automaton abbreviation, that's just the variable I invented. That's just the MIDI channel. That's channel 4. I could put 4 in there. It's just easier to program this way with variables, because if you ever want to change the channel, it'll change it for everything. turns the LED on, and then sends the program change for switch 1 and records the current patch is equal to 1, and that's only for one new function I've put in this file, which is how once for switch 5 the bypass works, which is different to the test bed. So again, ignore this one. I might do another video about what that does. So switch 1, switch 2, you can see this time current patch equals 2, program change equals 2. Same thing again. So it's all the same. The only difference is in switch 5. This is the bypass function. So I've got a switch, you'll see in the video, where I can bypass the unit or not. There's a bypass switch on the unit itself. It's just not easy to access the way I've got my pedal board laid out. And also this makes it a bit more intuitive in terms of what you see on the controller unit, MIDI controller unit itself. So what happens when you push the button 5, the bypass switch, is it first turns off all the LEDs, then it sends the control change to the automaton unit to bypass, this time value 0, which means put it in bypass mode where it's not affecting the signal, it's passing the signal through, and turn on LED 5. Then, when you press that bypass button again, it turns off all the LEDs, as they always do. It re-engages the unit by setting control change against 102 to value 1, and then it will turn the LED pin, LED number 5, off. I know I've got my ons and offs a bit out of order there. Might fix that later. Then it does one other thing. It says switch. This is a MIDI. This is an Arduino command. Switch current patch. Then this syntax here. These lines of code. What this is saying is, I want you to select from an array of statements. In this case, identified as case 1 through 8. Based on the variable that's in brackets here, and the variable will be current patch. So if the current patch value is 3, at this point it'll turn the LED pin on for number 3. So what this does is, when you press the bypass switch, it turns on indicating LED 5 and turns off everything else. When you press the button again, it turns off LED 5 and will turn on whatever the last patch number was before you bypass the unit. And it doesn't need to do anything else other than that, because the automaton preamp unit itself remains at whatever patch you last pressed, just in bypass mode. So that's just the way you'll see in the video. I like to organise it. It's more intuitive for me to say, when it's bypassed, it indicates nothing is selected, and when you turn it back on, it'll turn on the last one you picked and re-engage it. And button 6, 7 and 8 are just more of the same, of 1.1 through 4. I suppose it would have been more logical to put bypass as the last switch function. I just wrote these sort of the way they're set out on the board. You can do it any way you like, and the rest of this is all the same as it was before.